Hello everyone, Matt here from Code Tech and Tutorials. Welcome to another episode of Design Patterns. Today we're going to be looking at the command pattern. Really, I'm just going to show you how to code it up in C++ and just explain it as I go. Command pattern is very common in code in general. You might even use it without even realizing it sometimes, and it's also not that complex of code generally. So in general, any object you create to either do something or pass to something else to do something is probably along the lines of a command. Now let's look at the this sort of standard for making commands and how to program one up in theory. As you can see here, I've got a new folder in our design patterns project up on GitHub, link below, and we're going to do all the code in this command. Main is empty right now. There's the CMake for it. We've got that all added at the top level, CMake, so we're going to close the CMakes. We shouldn't need anything else. All right, first thing we're going to do is just make a header, and we're going to call this header just command is fine, command.h. And in this class, we want to do some base definitions of what a command is. So we're going to have a command interface. This way we can build commands and use some polymorphism power to process any variety of commands. So it's pretty standard to do something like this. Class, let's just do we'll call it base or just command. I'm going to call it iCommand. I like the idea of putting i's in front of interface classes. Just a personal preference. It's starting to grow on me a bit, and that just means we want to have some pure virtual function here, but we do want to do the standards for virtual classes. That is just make a constructor like so. It doesn't need to do anything, it just needs to exist. And then we want to have some sort of function here that we override. I'm just going to call it execute. That's pretty standard. Const, make it equal 0. So const because it's not going to change anything. It's just going to do some process, do the work in theory, the command, or maybe it'll send it off somewhere. We'll see. We'll get to that. But equal 0, of course, to make it an interface. So this is a pretty standard interface. And this will come in handy a little later, as you'll see. All right. So we have an interface for a command. What's a command look like? Well, it can look like anything. Here, I'll code up a simple basic one for you. Let's just say we have a command to print string command. This is going to be very basic public command, inherit right from iCommand. And in this one, okay, so it's print string. So we want to have whatever you're operating on, you probably want to keep in some sort of storage here. You don't necessarily have to. You probably want to. You'll see why here in a second. So privately, we're just gonna, if we're printing a string, we're probably gonna have a string that we're saving. I'm gonna call it payload because that's the way I saw it in an example, and I like that word. Public. For the next part, okay. So when people make this command, they have to construct it, right? We want to make the constructor very specific because we don't want people to goof around with this and do awkward things with it. We could even go as far to say that this is a final class. Don't further inherit from this command, but that's not really necessary at this point. But essentially, we want a constructor, and we don't want to allow people to construct it any other way. And so they need to pass in whatever the command requires. We're going to require some data, which is going to be the payload, and we'll just set it immediately. So this way, when you create this print string command, you need to create it along with whatever the payload is. And then the execute function should operate on that and do whatever your little command does. We need override here. Yep. In this case, we're just going to, we're going to print it. Just do it like this. And you can include whatever data you want to include in your execute function. In this case, hey, we're just printing a string. Maybe it's a log command, for example. Maybe that makes more sense. And then you could do other special stuff with this command. You know, it gets a little more complicated. Just making it a simple print, very simple, but not very useful. But what if you, for example, have a command that's a logger, and anytime you create it, you got to pass it in a string, and it just logs that. And then maybe somewhere else, you add in another little function here that allows you to change where it logs to. Like maybe you want it to print to a file instead of standard out. Then you could modify up this log command and have it do all that. And boom, there you got something semi-useful there. If you were to expand a little bit. So that's a little theory for how you would do just the little simple command. So let's go ahead and call it. Let's go to our main, make sure we include command, and don't worry, we'll get to a few more interesting examples later, but this simple use is sometimes all you need. So we might as well go all in on that. So we want to make a log command. It wants some kind of string. Let's pass it. This is my message log. That should figure it out. We probably need to include string here. Yeah, well, we need to include a string. Not necessarily there, but it's customary to put them at the top. But if I were working on this as a separate program, I would have this be in its own file personally. So that's why I'm kind of doing the includes below it. But it doesn't matter that much. You can follow your standards and not code the exact same way I code. It's fine. All right. So there we go. That should all compile. That should in general work, including commands should get us a string and IO stream. So there we go. So when we create this, it doesn't do anything. Now we got to call the execute on it. Oh, I'm also initializing incorrectly. The variable needs a name. I don't know. It's called LC. And there we go. So if we run this, let me just go to and there. Yep, that's it. And let's go ahead and give that a run. As you can see, we got the message to log. Okay. So there we go. There's a simple command. But usually they get a little more complicated. You know, you probably keep your logger simple enough. And, you know, expand it to switch between file or console want, or maybe if you add a graphical interface later, you could also change this log to also print to the screen somewhere on your graphical interface as well. So you could have it like, you know, it's a nice little contained log command that you want to add to your logger. You modify one area of code. That's critical. You modify one area of code to do this. That's like super important in these design patterns. I think a thing that might get overlooked a lot is that these patterns are here not because they're gonna try to think of a good way to word this. Basically, if you use these type of patterns, your code becomes a lot more easily maintainable, and that's a big reason. After going through a lot of these, I realized personally I need to refactor a lot of stuff in my game engine, and a lot of the code I was working on previously I could make in a more maintainable way. So if you don't know these patterns, you can still get stuff done. You'll just probably accidentally make it not very maintainable. It's basically what happens in the long run. That's my takeaway so far anyway. I'm curious to see what you guys think or experience. But anyway, let's get to the second part and make a more complicated command, because this log one was an example of a simple command. So we'll just put that example. Let's make an example of a more complicated command. And to be fair, when I was talking about adding all that special stuff about switching what it logs to, that sort of makes this a complex command if you do all that. Right here it's real simple because it literally just does one thing. All right, well, there's also another big difference about complex commands, and obviously that makes sense. Well, here the thing is, let's go back to the simple command and talk about why it's simple real quick. In general, with a command, you need something to receive the command. Now, in this case, what's receiving the command is generally the console out, which is part of the standard library. So we don't need to do a whole lot of work because we can just use that. It's like, hey, the receiver, who's the receiver? Oh, the console is going to receive it. That's what. So no need to do a whole lot of work. But if you have custom stuff going on, like for example, some rendering logic or some game logic, you might be passing this command to some other object known as the receiver. So instead of just your cout, you would have something else. So let's work up an example of a receiver. Now, the receiver is basically some class in your code that does some of your main important logic, and it will carry out some of these commands. All right, so let's make a receiver, a theoretical receiver. Now I'm just saying words. Now, what does this do, right? You gotta decide that. We could add a bunch of different stuff to this. Probably in the long run, you'll have a lot of stuff in here. Like for example, if we wanted to modify this to instead of actually print, maybe we could attach it to a receiver that has a print command. And that way, you know, let's not do that. Let's do a slightly different example. Let's do process A. Now it needs to take in something. It either needs to take in the command itself or just some important data associated with process A. So we'll just stick with strings for now, and we'll call it process A stuff. Sure, that works. And we'll do the same thing, just a process B and a process B stuff. And these will, you know, based off of what data you pass in, it's probably not going to be a string in your case because strings good for printing and maybe getting keywords, but when you get to more efficient stuff, you're often working with specific structures and states. So you might pass in that whole state structure or something like that. But yeah, just to give you an idea of where to go from here if you were to expand it. For now, let's just stick with, all right, we'll just say receiver is working on, and we could just say rock A stuff. And same here, B stuff. Maybe we want to say the function name too. Sure, we'll do it just to make it a little more clear. But essentially, you would have as many processes as you want or as you need, with taking in as many different things as you want. And your receiver is probably going to be called, like, I don't know, something else. It's not necessarily going to be called a receiver, is the point, but it could really want it to be. And yeah, so just more business logic. I don't know what to do here. Okay, so now that we have a receiver, this is going to expand how our commands can work beyond this simple pattern. This is where things get a little more interesting. So we're going to start out some of the same way. This is kind of also where you get to delegation, because sure, a command comes in, command gets delegated, and how it works internally in your receiver is totally up to you. If you want to put it on a stack or a queue and process them one at a time, you can do that. If you want to have certain ones create their own threads and do things internally, you can do that. So it gets this is why it's so useful, is you can basically design a program around these commands and have and it's a nice way to separate out like your interface of what you're allowed to do along with the internal of how those things are handled. All right, so let's make a more complex command. What do we call this? I don't know. I don't have a really good name for it here. Yeah, we'll just call it complex command now. And it's going to inherit from our interface again, because it is still a command, of course. Might think of a better name for the class here shortly. But this one, we want to actually have a receiver. So let's just privately make a receiver pointer receiver. Now, why is it a pointer, you might ask? Well, if it were its own object, then it would instantiate here, and we'd have an instance of the business logic inside every command. Definitely don't want that. That's why it's a pointer, because here we can point to the real receiver or the receiver we want. We actually might have multiple receivers, but you probably don't want to necessarily be creating them in commands. I guess you could if you really want to, but as things grow, it's going to get a bit messy. You probably just want something running, receiving, ready to go that you can say, here's a command, have this receiver handle it. All right, so that's private, so we'll get to that shortly. And we can also, if you've got any associated data, just like we had a payload here, we want those too. So in our case, we're just going to have some strings. We'll just call these same things. These are not references. I don't know, I'll call it details down here. But these could be any struct related to what the receiver can handle. Like this might be, if you're working on a renderer, for example, this might be all the render details or something, or it might be all the shader variables that need to change as a pre-render or something along those lines. But we're just going to keep them strings here because it makes for an easy, quick example. So publicly, we also want to do a very similar thing. We want to make a constructor and make that the only constructor. That way they're forced to follow this class. All right, so we need a receiver passed in. Let's go ahead and delete all these actually. So we definitely want to set the receiver. Like you absolutely have to set the receiver. So it's a pointer. Now there could be cases where this might be better as a reference, because there would be a bit of a guarantee that the reference isn't null. Because it still could be bad data though. But as a pointer, it's assumed that someone does the check beforehand, that it's not null, or we could handle it in the constructor and throw or something, but we're not really going to get too deep into that right now because that gets complicated. Personally, I'd probably use a shared pointer here. I think that would work great, but I'm not going to do that right now. And we also want what these process details are, so we just need to pass in a couple strings. Just call it A and B for now. And then you just want to set all these. You can do them right in line here. Let's do it real quick. I guess I'm going to break it to a new line because it's getting so long, and just set these strings like so. Just make it so that the compiler knows how to do it in a highly efficient way. Well, in general. But there we go. Now there's only one way to make a complex command. You need to pass it a pointer to a receiver and some details about the command is actually going to do. Now, what's the execute function going to look like? We do have to instantiate that. Let's see if Visual Studio will help us. Quick actions and refactoring. Implement all pure virtuals for class complex command. Will it work? Will it work? Will it cue the Jeopardy music? Nope. This has never worked for me. I don't understand why, but I don't know if it's something I'm doing wrong or something Visual Studio's doing wrong, but I can literally never get that feature to work. I don't know why it's even listed there or if it works for other people. Let me know. Does that work for you guys when you go here and do the implement pure virtuals? See, right click on the class, quick actions and refactoring, implement all pure virtuals. This never works for me. Reason, it failed. That's why it couldn't, because it failed. Okay. That's the worst details ever. Can you tell me why it failed? Anyway, side rant over. Let's make this execute command. So let's just override it. Void execute const override. And we basically want to pass this along to the receiver. So we know the receiver's set. So we can just go receiver and then call one of these functions, whatever one we need from the receiver to do stuff. Well, you might want to check these first before you call them, or you can just pass them along directly and say, hey, I got some process A stuff, process it. So however you want to set that up. Personally, I think it's a good idea to keep the logic in the command as simple as possible and start doing all your more interesting things in the receiver. So I'm not going to do any checks here. I'm just going to pass it along. If the internals want to throw the errors or whatever, notify us, set the data, it's garbage, they can. But the complex command, we're not going to do that. We're just going to pass along the details, and that's it. So when this runs, it should use this receiver here. We could make it a little more explicit and put the this keyword, since I guess there's a potential that you do multiple inheritance, like you do something like, I don't know, log command, right? Which is still going to be about the same, except what if log command also has a receiver? Then it's going to be like, okay, well, which receiver are we using? So that's why this clears that up sometimes, but actually not necessary, I don't think here. Let's revert this. Just wanted to give you an example. But that's why you might use something like this. I'm not going to put it there. I don't think it doesn't make it any clearer in our case. It's fairly obvious. That's the one. All right. So now if we instantiate a complex command, we also need a receiver. Let's go ahead and do that. Okay. Go down a few lines. So we go, okay, well, actually, we need to make a receiver first. Receiver. We'll just make a receiver called rec. It could be a recorder. You could send, for example, if you were recording, you could have a receiver that you just send a picture of every frame, and it saves that and into, like, you know, an MP4 or whatever you're recording as. So you could, you know, make a command as a recorder. Just another thought example there. But anyway, okay, so you have a receiver. You could make it a pointer and do new and delete if that's what you want to do. But if you're in the same scope here, it's not too big of a deal. Let's make a complex command, and we'll just call it CC for now. Now this one needs to be instantiated with some stuff. We look at the constructor that we just made. We need a receiver pointer, a string, 2 strings. All right, so let's go ahead and do that, because it should not compile. Let's just say play without giving a thing. Yeah. Oh wait, I might have typed with something. Let's make this code correct. Yeah, this isn't going to compile because this constructor is wrong. I don't know if this is a cascade of errors from that or something else. So we're going to finish this. All right, so it needs a receiver, string A, string B. Just keep it that simple. All right, so this wants a pointer. So you can make a little reference there, which will basically say a pointer to the start of the data, which is a pointer. So that's fine. And yeah, of course, if you made this pointer to begin with, you don't need the reference thing. It doesn't turn it into a pointer. It just passes along a pointer to the start of the data. All right, then, which is what a pointer is. So we don't want to go too deep into that. You guys probably know all that already. It's more a different subject. But let's go ahead and run this now and see. Well, we got to call execute on this so we can see the end code. So we'll get our basic log command, and then we should get some messages for that last X there. Okay, we have some errors we need to fix. Mainly this process, this execute here needs these details as they're set, not the ones in a different function that don't exist. Okay, I've discovered that all these errors stem from me spelling receiver wrong, essentially. So let's just spell receiver correctly. Okay, there's our original one. There we go with process A, process B that are being passed into that complex command and then passed to the receiver they attach to. So another cool thing about this is you can change receivers on the fly, which is super cool. Of course, you probably want an interface for them if you're making a bunch of them. That way this can be adaptively changed easier, but just have one main one. That's fine. But you could, in theory, set some public functionality like change receiver and take in a new one. So mid-program, you could switch it up like so. And if you're doing that, you probably want to, you know, just make an interface, and that way you can have multiple receivers. But that's it's kind of going down a deeper route that, well, still somewhat related to the command pattern. It's, you know, if you need to do it, you do it. If you don't ever need to switch commands and you're good with the one, you could just leave it as it is. So the point is, you should be somewhat comfortable expanding these or thinking about what else you could do. And that's kind of the point of this series too. Because if you're having a hard time going beyond the base examples of and thinking of other things you might be able to do, you might be at a different phase where you're not ready to hear all this, I guess. It might be, not necessarily, but I don't know. All right, so that all works. There's one other thing I want to show you here, because yeah, sure, that's cool. And sure, you could change receiver and call execute again like I was talking about. If you want to work up that example and try it out, cool. If you want to even add it to this repo, just make a pull request and I'll add it in. That'd be cool. But the other thing I want to show you is now, see, these are kind of operated on individually, just in our main. Usually you have some sort of, I guess what they call an invoker, or this might be kind of what wraps all your core business logic, I guess. And an invoker typically handles a bunch of different commands, so you can set all of those. In my case, for like my game engine, for example, my main loop is somewhat of an invoker. So when I execute my core main loop, it goes through a bunch of stuff and does a bunch of stuff. And I'm actually refactoring that currently. After going through a lot of this stuff, I'm starting to realize it could be better. So let's make an example of an invoker. I think I'm actually just gonna, we'll put it at the bottom of command. You should probably have this in a different header, but let's just make an example. So class invoker, we'll just call it invoker, what most examples seem to use. But this could essentially be your main, I guess, probably a loop or something. You can call it what you want, but it invokes things. So it's going to invoke commands, basically. Now, you want to privately have all the commands it handles. So we might have command 1, command 2, I don't know. It's totally up to how your program runs. We could have a startup command. We could have a, I don't know, mid command, and we could have like an exit command or a shutdown command or something. I guess it would be more like on, I don't know. You can name them as appropriate for your stuff, but in my case here, I'm just going to do these once. So just on startup, on mid would be like maybe your core inner loop that goes over and over or something. You might have a bunch of different commands there around a while loop or something that, you know, may pass along to receivers, whatever is going on. So you'll need to maybe design receivers because the invoker doesn't necessarily hold receivers. I guess it could, but that'd be a little odd. They're supposed to be separate. All right, that's enough for the private variables. So let's publicly just make some stuff here. Since these are pointers, we actually need to delete them when we shut down. Now you would think the same way for this complex command here, that you probably want to delete on shutdown too, but that's not the case. You actually don't, because it does not own the receiver. That's probably why it'd be good as a shared pointer rather than a unique one, because actually this receiver is owned by the parent process, which in our case is our main. It's got the receiver. If we delete receiver when this command goes out of scope, for example, if we do this, we are removing this data when we shouldn't be. That's not good. Just an example there of why we don't own the receiver here. So maybe we should even make a comment not owned. Probably should be refactored to a shared pointer. That's my opinion. That would make it more maintainable, but if you don't watch the video and you just look at the code, you're not gonna know. Well, now you will, I guess, since there's a comment. All right, but in this case, we're probably gonna own all these commands, although not necessarily. But if you do own them, you need to delete them. So we're going to make a deleter is what the whole point here. And it's just going to call delete on all these when the invoker goes out of scope. All right, that's taken care of. So you could make a constructor for invoker that takes the commands, but the thing is, you might just want them to be null sometimes. Sometimes you might not want these to do anything. So you might not have a startup command. So you're like, okay, I don't want to force it to be set. What if we don't have one? Or I guess you could have it default to null in your constructor if some are forced to be set. But that's a decision for you to make in your design. What you also could do is you could just have functions to set them, like set startup command. And it would just take a command that you pass in. We'll do a pointer here again. Now these are going to be owned, as you can see, since we're deleting them, claiming that we own them, basically. So whatever we pass in here, we probably either want to construct in line. Yeah, probably just want to set construct in line. And you'll see that in the main shortly. But let's, for example, just make these set mid command, set shutdown command. All right, and these will do basically as you expect. We're just gonna copy pointers. There's probably a better, more efficient method, but copying pointers is relatively cheap. It's not that big of a deal, but just keep in mind that, hey, if you're going for maximum efficiency, any general tutorial you see anywhere needs to be taken with a grain of salt. When explaining and teaching things, efficiency is nice, but sometimes it convolutes the real lesson. That makes sense. So a lot of people just leave it out. I'm trying to kind of explain when I'm leaving it out. That way you at least have an idea. But yeah, just in general, grain of salt. All right, so if you can set all the commands. Now we just want to have an operation that like runs them basically. This would probably be called in a loop somewhere, depending on how you want to do it, or maybe it just goes through it once. But you can basically set up sets of commands with an invoker is the nice thing. So let's just say do the work. We'll call it that. Just a generic public function here, and it's just going to call all of these that exist. So say if on startup, basically if it's not null, I guess I could make it more explicit, not equal to null. Actually, I like using all lowercase null pointer, but you know, you don't have to put that in there. You can just leave it like that. It's the same check. If not null, then we want to run it. We want to run the command. So you would just go say the same command and just call its execute method. And we'll just do that for all of these basically. So if they exist, we'll run their null. Nothing will happen. So there we go. So there's a nice little invoker there. Now let's use it in our main to show as an example. And you'll see something super cool here in this example coming up. And it's basically that while this invoker, you know, knows nothing, it just has commands. You can make these either simple commands, like these log commands. So you could do that, or you could make them complex commands that have receivers set up. So it's a pretty cool way to design your program. Okay, let's go to this next one. Invoker example, invoking subcommands demo. There we go. So here we of course need an invoker, and it takes 3 operations or 3 commands. So we need to build those commands. We can do them in line as new. And it's going to get a little interesting, but sure, whatever. Let's just make 3 log commands for now. And we could, for example, just say starting up, mid time. Oh, we can do some quick logs like that. Oh, I need to give invoker a name, obviously. We'll call it invoke, just lowercase invoker. I've clearly done something wrong. Oh, yeah. I didn't make a constructor. You know, I talked about making a constructor that did this stuff, but we're not doing that in our case. Instead, we're making it so that you can modify the invoker on the fly with set these commands. So this is what we have to do. Since I talked about it, it was stuck in my memory like I actually did it. And we'll just do these other ones. Very similar fashion. There we go. We've set all the commands. Now when we call the invokers do the work, we should see these 3 logs. Now I'm pretty sure our current logger, let's take a look at it. Oh, it puts in new lines. Oh, wait. Yeah, it puts in new lines. So we should see print string and then the whatever and then a new line. Okay, so let's go ahead and run this. Oh, let's fix our errors. Right. We name these I command, so we gotta make sure we call these the right thing. A few little syntax errors there. I think that's the only real error we had. Yeah. Okay, and there we go. Those are the first two that we already went over. This is the one we were just going over, and we see we got a starting up, mid-time, and a shutting down. We got all three operations going on the invoker. And as you can see, as you go through your program, you could change up these commands, but you might have this, like, what I would be doing probably, I don't know. It just depends what you're making your command for. But the invoker essentially allows you to batch together a bunch of commands and kind of modify them as needed. I guess I'll do one more quick thing. I'll just say, okay, so what if our mid command, we wanted to have a receiver because we didn't want to log, we wanted to actually do some real stuff. So we could pass in, I don't know, we've already built this one in this complex command. We can just pass it in here actually. Now it wants a pointer, so we'd have to do a reference and that would set it up. And we should get the message that this one does on execute. So let's go ahead and do that. Now this is already set up with the receiver and everything. So as long as the receiver didn't go out of scope or something, then we're fine. All right, let's hit play. And there we go. We see now in the thing, instead of mid process, we get receivers working on it. So yeah, I guess the whole point is that you can, these invokers, well, they don't know about the receivers. The commands have them in them, so you can really make your code super modular with this kind of setup. In general, there's just a lot of places you can go from here. And I think that's all I've got for this video. I hope you've enjoyed it. Huge shout out to my patrons. You guys have really made a huge difference for me continuing this sort of work. And also huge shout out to the biggest website that I found to be a great resource for learning these patterns. And if you want to do additional reading, I would highly recommend them. And it's just this refactoring.guru site. I love their explanations. I love their code. I think they did an excellent job. If you want to understand the command pattern more, they have code examples in C++. Mine is derived from that in this code at least. And it really helped me with an understanding. And of course, you can just read about it too. They have just a pretty good, it's kind of long, but yeah, you know what? Actually, I will read through all this, do an audio recording of it, and post it on my Patreon just as like a bonus. So if you just want to put on headphones and hear me read all of this from their site, subscribe. As little as $3 a month and get random extra stuff like me reading this whole command thing. And maybe that'll help if you just kind of want to sink in, let it sink in passively. Yeah, I think that's all I got. Thanks, guys. I'll see you in the next one.